Hello, today I have 4 power adapters for one video. This is the AOHi round of tests, from 20 watts to 100 watts. These are all wall adapters that range from the very small up to the fairly large and heavy. Stick around to find out if any of these are winners. In this series I try to answer the question, which power adapter do I want to get? The videos get technical, so hang on and always ask questions if you don't understand something. The performance is measured and compared to near competitors to see how each one stacks up. If you want to help out the channel, see the links on my webpage or in the description. Patreon is now live as well as the super button. Thanks to my current patrons. First up, we have the 20 watt AOHi MagCube power adapter. It's a 20 watt single USB-C port adapter, and the box doesn't have much to say. It does come with 2 power adapters in one box. We'll have to find out if this is good value or if they're just trying to get rid of things. The user manual for this is fairly basic, not a ton of specifications, but enough. The power adapter itself is very small, and is on par in size with the Ugreen or the Anker 20 watt adapter, but substantially smaller than the Apple 20 watt adapter. It does have an ETL safety listing, which is good for an inexpensive adapter. It's a nice add. Being a single port, power sharing isn't an issue. The power adapter does only supply 5 volts or 9 volts though, so this is not a good go-to universal adapter. A unique feature on these power adapters is a little LED light. It looks like it shows green for minimal power draw, yellow for half power draw, and orange for full power draw. Sometimes the LED will have a breathing effect per the user manual. This is a little different than other adapters and not a terrible feature. Alright, let's go through the weights for all these adapters. The 20 watt adapter packaging weighs 24 grams and the power adapter weighs 36 grams. Quite light. The 30 watt adapter packaging weighs 73 grams. This does include a USB-C cable. The 30 watt adapter weighs 40 grams. This is barely more than the 20 watt adapter, and in fact is the exact same size as the 20 watt adapter. The 65 watt adapter packaging weighs 24 grams, and the 65 watt adapter weighs 98 grams. For the power, this is pretty lightweight. The 100 watt adapter packaging came in at 70 grams. This also includes a cable, and the power adapter weighs 232 grams. It's about 20 grams heavier than the Anker 736 100 watt adapter. Size-wise, they're similar. The 30 watt power adapter shares a lot of things with the 20 watt adapter. They both have safety listings, they both have the LED, and they are in fact the same size. The 30 watt adapter does come with a USB-C cable though if you need this. The adapter also has quite a lot more to offer for voltage modes, and it can power many more types of devices. For the USB power delivery modes, the fixed output voltages are 5, 9, 12, 15, and 20 volts. The device also has an 11 volt PPS mode, which is a variable output voltage mode. Your device selects which one of these modes is most appropriate for charging. You should be able to charge anything from a watch to a laptop. The 65 watt adapter scales things up from the 20 and 30 watt offerings. They share the safety listing, they have the LED, but this adapter also offers a 21 volt PPS variable output voltage mode. The 65 watt adapter is missing something though, and it looks like all the adapters in the 65 watt class seem to not bother with power factor correction. The power factor correction is a technique to consume AC power as efficiently as possible. The higher the power factor, the lower the comparable current, and therefore the lower the loss in the wires and transformers that supply your power. At this power level, I guess it's deemed not necessary. Here is the 100 watt power adapter. We can see the 2 USB-C ports. This has a marketing label of GAN+. No idea what that means. This device does have a safety listing for the United States and Canada through ETL. It has the DOE 6 efficiency rating, which we'll have to see if it actually meets that. The LED light is common across all of these adapters. The 100 watt power adapter offers the same modes as the 65 watt adapter. This does have some power sharing between the 2 ports, and when you plug and unplug cables, it does require renegotiation of the USB power delivery. The question on this power adapter is, does it have or not have power factor correction? Once plugged in, the power adapter uses tiny amounts of power at idle. The only major difference in the data is the 100 watt adapter spikes a little higher on the VA side. All of these power adapters meet the DOE 6 efficiency requirements, which is a nice plus for a power adapter that gets left plugged in. The 100 watt and 65 watt adapters do behave a little differently and have low distortion on the idle mode as well, versus the others, which are basically off the charts. The 20 watt power adapter is not great. It looks like it's leaving some performance on the table. The 30 watt adapter steps up the performance a lot more, and it's offering quite a bit more value with its ability to charge just about anything in a compact package. The 65 watt adapter went for compactness at the sacrifice of AC power performance, and the 100 watt adapter tries a lot harder. It has the low idle power consumption, but it suffers from an issue where we've seen on many of the 100 watt mid-tier adapters. This one is different though. The adapter does appear to have the power factor correction, but it decides to turn this on at 50 watts. Not exclusively in the 20 volt mode, but it does require the power level to be at least 50 watts to turn that on. At least it has the power factor correction sometimes. The devices all stayed within the basic requirements of the USB power delivery specification for DC output voltages. At full load, here are the graphs of the current, voltage, and power. The voltage is always a nice sine wave. The current and power, however, are not pretty on any of these. Even the power factor corrected adapter looks like it's struggling a little. At 20 watts, 30 watts, and 65 watts, the performance is nearly identical. At 100 watts, we see the power factor correction kick in and is trying to keep that current in check. Okay, let's take these adapters up to overload. This is how much power they can put out beyond their rating before they safely shut down. See how far I can push them. The 20 watt and 30 watt only gave a couple of extra watts. The 65 watt is an overachiever, pushing over 80 watts before it finally shuts down. The 100 watt adapter split the difference and gave a reasonable 12 extra watts. These are all safe overload thresholds. The 65 watt is pushing it though. The power adapters do all recover to 5 volts once the load was turned off, so this does mean the cable can be left in place. The data for the 20 watt adapter shows that it has some issues. The high THD in all modes means filtering was considered an afterthought for the sake of smaller size. It doesn't take much, but in this case they didn't bother. This takes one of the lower spots on the scale. The 30 watt improves the efficiency a little bit, but it still suffers the same issues as the 20 watt adapter. As we saw in the graphs earlier, the peak currents are very high on these adapters, causing some issues with the lower power numbers. The 65 watt does at least improve things on the idle side. The idle THD is low. It doesn't have active power factor correction though, so we mentioned that earlier and we saw that this is typical for 65 watt adapters, but it does hurt the performance. The 100 watt adapter is one of those tales of two adapters. In this case, the idle and the high power states look great, and everything in the middle, where you're probably going to be using this power adapter most of the time, looks awful. So unless you're hammering this adapter with at least 50 watts all the time, it's not the best choice. In comparison with other power adapters, these adapters span a wide gamut of performance. The 20 watt adapter is quite bad. The 30 watt adapter steps things up a little bit, but still not amazing. Not as good as the Belkin 30 watt adapter. The 65 watt category doesn't have a lot of reported competition, but this still doesn't top that measure. It's getting bested by the no longer available Amazon adapter. The 100 watt adapter finally steps things up a little bit by offering the power factor correction in some modes, but it's still not enough to make it a top of the class adapter. Final notes. These power adapters are not class leaders. These power adapters show that the market can push out power adapters that meet safety listings and the bare minimum requirements for the power efficiency and idle requirements, but do not try to go above and beyond. The 100 watt power adapter has power factor correction, but is only used in the modes above 50 watts. So you can get stuck on this one. For a price point, these span from $13 to $80. On the low end, you get what you pay for. On the high end, you don't. The AC power and DC power stay within reasonable limits, and the device tolerates overloads safely. All the devices carried safety listings. We can see the build quality doesn't look bad, and overall, the adapters have a unique LED feature to help them stand out. I have seen these adapters being pushed pretty strongly online, but it is a new brand, so as usual, the decision has to be yours if one of these looks like it's going to be worth it. I don't have any long-term tests on these, and I don't plan to use these in the long term. The adapter that gets the win for AOHi is the 100 watt one, of course, but it still doesn't top the class leaders. Next week, the plan is to get lost in a mountain of USB cables. Round 3 of the USB cables should finally be done by then. I have many more of these adapters to get through, so many more videos in the future. Thanks for watching, and bye for now.